Hello, thanks for clicking. Welcome to another Nargilus 2 production. Today we're going to be talking about geometric series, and we're going to get started with all of our series tests. All right, so let's take a look about what this entails, what it's all about. Remember, in the last video we talked about partial sums, right? Sequences of partial sums, okay, being used to determine whether a series converges or diverges. So let's talk about how this geometric series concept relates to that. All right, so in math, we always want to find ways to do things easier, okay, than the ways that we currently know them. So right now, we know that a series converges or diverges based upon the sequence of partial sums that we write and the nth term of that sequence converging or diverging, okay? But here's the thing. You could see what we did in the last video with all of those different terms, trying to write the nth term for the sequence of partial sums, finding all the partial sums. We don't want to do that every single time. Every single time you write another series, you have to write down all of its individual terms, then find all of the partial sums, and then create an nth term out of it, and then find the limit as n goes to infinity of it. That's a lot like work. So we don't want to do that. So what we've done is mathematicians have developed many number of tests that can be used on a series to determine whether it converges or diverges. Today, in this video, we're going to begin looking at these tests, okay? The first test that we're going to be talking about today is the geometric series test. So, a geometric series. Here is a sequence, 5, 10, 20, 40, 80. Could we write an nth term representation for this series? Well, let's take a look at what's happening. In the series, we're multiplying by 2 each time, right? Or in the sequence, sorry, we're multiplying by 2 each time. And the sequence starts with 5. So a sub n, let's start from 5. And we're going to multiply by 2 to the, let's say, n minus 1. Would that work? So let's see. If I have n equals 1, a sub 1 would be 5 times 2 to the n minus 1 minus 1. That would be 5. If n is 2, a sub 2 would be 5 times 2 to the 2 minus 1, which is 5 times 2. That's 10. If n is 3, it would be 5 times 2 to the 3 minus 1. 5 times 2 squared, that's 20. Yes, it looks like it works. Okay, so we're starting from 5, and then we're going to multiply by 2 to the n minus 1. Now, let's take a look at, this is an example of a geometric series, okay, or an nth term for a geometric series. All right, let's take a look at what the definition is. So, the geometric series test. A series of the form, the sum from n equals 0 to infinity of a times r to the n is considered to be a geometric series. So this actually is the same series that I had on the last slide. We wrote it like this. Well, we did it as a list, right? So we didn't do it as an actual series. We did it as a list. We had it as a sub n equals 5 times 2 to the n minus 1. Okay, we started at 1. But if you were to start on 0 instead, a sub 0, a sub n then would be 5 times 2 to the n, because then n equals 0 would be 5 times 2 to the 0, that's 5. Then n equals 1 would be 5 times 2 to the 1, that would be 10. Okay? So we just changed the counter and started the counter at a different spot. All right, that changed our series to 5 times 2 to the n. So a series of the form the sum n equals 0 to infinity of a times r to the n is considered a geometric series if the ratio r, okay, in our case, that would be 2, is between, or the absolute value of r is between 0 and 1, the series converges. Some textbooks write it as r has to be between -1 and 1. It's the same thing. You're just solving this absolute value inequality for r. So you can write this or you can write that. Both of them are valid. If the ratio r is greater than or equal to 1, then the series diverges. All right. So that would mean that if r is greater than or equal to 1, or r is less than or equal to -1, then the series diverges. Okay? All right. If the series converges, it converges to a sum. The sum of the series will be a over 1 minus r. However, the series must begin at n equals 0, so the counter must begin at 0 for the sum of the series to be represented by this equation. All right, so we're going to see that a little later on today. Okay, first thing we're going to do is actually try to work with the series. So what's important from here are a couple things. Number one, you need to be able to write the series in this specific form for it to be a geometric series. All right, and to use the geometric series test. If you can't write it in this form, then you can't use the geometric series test. Okay? To figure out if the series converges, you need to know that the absolute value of r is less than 1 or r is between -1 and 1. Okay? Then that series will converge. If the ratio, again, if r is less than or equal to -1 or greater than or equal to 1, the series will diverge. You need to know that as well. And then you need to know what the sum of that series is, a over 1 minus r, as long as n starts on 0. All right, so let's first work with the form. Let's state if the series here is geometric. And if it is, we're going to decide if it converges or diverges. So remember, a geometric series has the form the sum from n equals 0 to infinity of a times r to the n. Okay? All right, so also keep in mind that n does not have to necessarily be 0. N can start at any number. It can be 1, 2, 3, 4. That would affect the sum of the series, but it would not affect whether the series converges or diverges or whether or not it's geometric. All right, so we'll see that in just a moment. Okay, so let's take a look. Here's our first series. It's the sum from n equals 0 to infinity of 3/4 to the n power. So we're trying to get a series to look like this, a times r to the n. Well, I certainly have an r to the n. You can see it, okay? The question is, what would a be? Well, there's no number in front here, so there's really a 1 there. So this is geometric, okay? It is geometric. We know a is 1, r is 3/4. Now, this series will converge if r is between -1 and 1, and it is. So this series converges by the geometric series test. Okay? This series converges by the geometric series test because r, 3/4, is between -1 and 1. A does not matter. All right? Okay, next series. We have the sum from n equals 0 to infinity of n over 2 squared. All right. Now, here's the thing. A and r must both be numeric values. So in this case, a is 1. But r is not a numeric value. R is n over 2. All right. It's not 1/2. It's not 3/2. It's n over 2. And n is going to change depending on this counter. Okay? So this series is not geometric. It's not geometric. I cannot use the geometric series test to determine whether it converges or diverges. I just have to leave it for now. All right? All right, let's try the next one. So now n equals 1. The counter is not at 0 anymore. That's okay. So we have n equals 1 to infinity, 5 over 6 to the n. Well, that certainly doesn't look like this to begin with. But if we manipulate it a little bit, like let's say we put the 5 in the front and change this to a 1 over 6 to the n. But wait a minute, 1 over 6 to the n, isn't that just 1/6 to the n power? Because 1 to the n is just 1. And 6 to the n, well, that's down there. So yes, this is a times r to the n. This is geometric. Okay, we know a is 5, r is 1/6, and since r is 1/6, r is between -1 and 1, so this series converges by the geometric series test. Okay? All right, let's try the next one. N equals 1 to infinity of pi to the -n. Again, certainly doesn't look like this, but we can change it around. What if we wrote it as 1 over pi to the n? And then we could rewrite it as 1 times 1 over pi to the n. Okay, well, that looks like a times r to the n, and that is geometric. All right, so it's not just as easy as just kind of looking for this every time. Sometimes you have to manipulate it. All right, in this case, r is 1 over pi. Well, pi is 3.14, so this is like 1 over 3.14. R is, in fact, between -1 and 1, so this converges by the geometric series test. And finally, we have one. This one's actually in the right form. A times r to the n. A is 1/2. R is 3.6. This is geometric. But 3.6 is greater than 1. So this series diverges by the geometric series test. Okay? So that's how we recognize, we're trying to recognize this form in a series. All right? Okay, so finally, let's decide if these series converge or diverge. If they converge, we're going to find its sum. All right, let's take a look at the first one. So the first one is 4 over 2 to the n. Okay, so take a minute, see if you can convert it. So that's 4 times 1 over 2 to the n, but that's really 4 times 1/2 to the n. Well, there's my a, there's my r. So in this case, r is 1/2, so it is between -1 and 1, so this series converges. And now to find the sum of this series, I'm going to use the formula a over 1 minus r, again, as long as n starts from 0. Okay, so then a is 4, r is 1/2, so that's 4 over 1/2. So that would be 8. So the sum of this series is 8. Okay? So not only do I know that it's a geometric series, I know it's a convergent geometric series, and I know its sum is 8. And what I've just done by doing this little small calculation is I have avoided writing down all of the terms that are added in that series, then finding a list of all of the partial sums, turning it into an nth term, and finding the limit as n goes to infinity of it. Okay, I just avoided all of that. All right? Okay, so now, here's another one. Now, this one's actually in the right form, a times r to the n. It's right there for you. Okay, so r is 1/3. That is between -1 and 1. So this is a convergent geometric series. All right, by the geometric series test. Now I want to find the sum of it. The sum is a over 1 minus r. But the problem is n doesn't start from 0. It's supposed to. Okay, so to find the true sum, n has to start at 0. You have to start finding the terms of the series at 0. If it doesn't start at 0, you're going to have to take away from the sum, because this sum includes n equals 0. So you're going to have to take away the n equals 0 term. So n equals 0 would be 3 times 1/3 to the 0 power. So that would be 3. So to find the sum, I'm going to have to take a is 3 over 1 minus r is 1/3, and then subtract 3 away from it, because that's where the sum or the series should have started, and n equals 0 is included in this calculation. I have to take it out because I'm not starting from 0, I'm starting from 1 instead. Okay, that's how it works. All right, so we got 3 over 2/3 minus 3. So if I flip the 2/3 over, that'll give me 9 over 2 minus 3. That's 4.5 minus 3, which is 1.5. So that's the sum of that series. Okay, that's how I find the sum of a geometric series. Now, again, keep in mind, I'm only able to find the sum of a geometric series if the series converges, right? If the series diverges, it doesn't have a finite sum. That's the definition of divergence, okay? So keep in mind, the series has to converge for you to use this sum formula. Otherwise, you can't use it, all right? And that's our first series test of many. As always, thanks for clicking.